For the next several minutes, let's talk about phosphorus and soil testing and what typically occurs here in Ohio and some of the surrounding states. So some generalizations. Phosphorus fertilizer management in agroecosystems or in ecosystems in general are often, and in fact, almost always based on soil testing. All right, so soil testing results from trials over decades and decades have led to how we manage phosphorus as a fertilizer in this region and in other regions across the US and the globe. Some recommendations for new people that are just starting out quantifying phosphorus in soils is to soil sample every 3 to 4 years at a minimum. And in fact, sampling yearly is probably the best until you get a good idea of the actions and reactions of phosphorus in the soils that you're working with. When you have a test done, you should be using a reliable soil testing lab that's experienced, that's been around a while. Or if you have to use a new lab, you should probably talk to the lab itself and understand the experiences that the lab manager and lab personnel actually have. And when you send a sample in and you get a result back in terms of how much phosphorus to apply per acre, the application rates that you receive or the application rate that you receive is simply based on a lot of correlation and calibration data that's been collected over decades, probably 50 to 70 or 80 years worth of data collected to come up with those recommendations, right? And so these recommendations are simply recommendations where we see a certain percentage of a response due to a certain application rate to corn when a soil has X amount of P2O5 present in it, okay? The recommendation is not going to work all the time, to be honest with you. Sometimes it works, sometimes it doesn't work, but it's based on decades of research that have gone into that recommendation. Here in Ohio, in the tri-state region, this is how we approach the recommendation for application rates of P2O5. We use either a maintenance approach or a buildup and maintenance approach, and you can use either one, right? So this graph shows you how this works in this region. So we want our crops to be sort of in this zone here. It says maintenance crop removal, right? We want to start the season in this box. If you're below this box, you're deficient, right? So you're to the left. And a yield response to fertilizer most likely will occur. So you pull a soil sample, and let's say you're down here in the bottom left-hand corner of this figure. So you're going to add a fertilizer to bring you up into some soil test level that's optimal, right? This optimal zone is where a yield response to fertilizer is not expected. That doesn't mean you might or might not see it. You might see it, but this area of this box is where a yield response is really not expected. So we want to push our soils from the deficient into the optimal. Okay, and we learned a little bit about these terms way back in, oh, was it Unit 1 or Unit 2? And then there's a point on this figure, or in this figure, where above you are sufficient, and there's no agronomic reason to apply fertilizer. So if you are way out here to the right in this figure, there's no need to apply fertilizer. So don't apply fertilizer because you will waste your money. So if you look at, those are the three zones on the x-axis. If you follow the dashed lines vertically, there's a critical level and a maintenance level. And we want to be between the critical and maintenance level. And if you're well below this critical level, what's recommended is to start building the amount of phosphorus that's present in the soil to above the critical level and then maintain, okay? And so you'll see that on this next slide. So in terms of soil testing, this is what occurs. A soil test phosphorus value is something that the soil testing lab or a soil testing lab will provide you. And it's simply determined by a chemical procedure that theoretically extracts a portion of the soil phosphorus that the plant could see over a growing period. And this chemical extractant is certainly not the solution or liquid phase that a plant would exude, but it mimics what we feel is going to provide you a good estimate of what a plant needs for a certain yield, and we can use those values to estimate fertilizer recommendations. So this extraction is used to estimate plant availability of, in this case, phosphorus. So the soil test phosphorus value is simply an availability index. And sometimes it's right and sometimes it's wrong. And what do I mean by that? These availability indices have some range of yes, it works or doesn't work, right? Confidence intervals. And it might be 90% confident that this is going to work or 85% confident. But these availability indices have been tested over decades, like I've mentioned in one of the previous slides, and it works pretty well. So this is what happens. The soil test results have been correlated to field observations from decades worth of work and of plant response to added phosphorus fertilizers in order to develop the recommendations. For example, what you see here on the bottom of this slide. What you see on the bottom of this slide is from the Tri-State fertilizer recommendations for these 4 crops: corn, soybean, wheat, and alfalfa, right? And the approach that we take here in Ohio and the Tri-State region is maintenance, right? So the maintenance approach that you saw on the slide previously is a range that we want to target. So we use something called Melic 3, right? This is the solution that's used to extract phosphorus or a portion of the phosphorus that's present in the soil that we think is what the plant will see, say, over a growing period. And we use a maintenance approach. And that maintenance approach tells us that for corn, either grain or forage, and soybeans, we want to be between these values, 20 to 40 parts per million. If you're above this value, you are in the sufficient range and you do not need to add a fertilizer. And if you're below 20, you're in that deficient range and you need to add fertilizer. The same thing holds true for wheat and alfalfa. There's a range. This is the maintenance range that we target. And I'll give you a prelude to the potassium unit because we follow the same approach for potassium as we do for phosphorus. So next, what I want to do is describe the common soil extractants that we use to test whether or not we're in the maintenance range or not.